Well, welcome to this online revision session for AQA FP3, in which we'll be looking at the June 2010 question 3 on improper integrals. As you can see in this question, the first part you have to explain why this is an improper integral. The second part then asks you to work out what this integral is, and you need to recognise the process that you're required to use here will be integration by parts, and then finally to use the limiting process to evaluate this integral between 1 and infinity. Well, first part, stating why this is an improper integral, we can see straight away that the top of the limit here of the integration is from 1 to infinity. So the interval that we're required to integrate over is infinite. Okay, so immediately that's the case of one of our definitions of it being an improper integral. And that's all you need to state in order to get 1 mark associated with that part of the question. Second part then is you need to recognise here we have 4x multiplied by e to the minus 4x, so we have a product, and so the method by which we integrate this will be integration by parts. So one part you identify as u that you're able to differentiate, and the other part you recognise as dv by dx, from which you then integrate. And the key thing here is to choose u as being equal to x, so when you differentiate it you'll just end up with a constant. Okay, so that's what we're going to do. We'll let u be equal to 4x dv by dx will be equal e to the minus 4x. And then from that we can write down that du by dx is equal to 4, and that v will be the integral of e to the minus 4x, which will be, of course, e to the minus 4x, but you also know the differential of the minus 4x is minus 4, it's a constant, so we get minus a quarter of e to the minus 4x. And so we call this integral I. To save a bit of writing, we'll get the fact then that I becomes, we know the result is uv minus the integral of v du dx, so this becomes uv, so that's minus 4x times the minus a quarter e to the minus 4x, which is just going to give us minus x e to the minus 4x. Then it's minus the integral of v, well v is minus a quarter, so that will give us plus a quarter e to the minus 4x times 4 from the du by dx. And so if we now evaluate this, we will get minus x e to the minus 4x, and then the integral of this, well again we're back to the fact that e to the minus 4x integrated is minus a quarter e to the minus 4x, and of course the quarters here and the 4 have disappeared, so this becomes minus a quarter e to the minus 4x. And since this is an indefinite integral, we need to include our constant of integration there at the end of it. Well, what do we get? We get 3 marks for doing this part. Well, for recognising that we're going to use integration by parts, gives us 1 mark for the method, and for obtaining the correct expression that we need to integrate we get 1 mark, and then for finally completing that second integration will give us an additional mark. And finally, into part C, we're asked to find the integral from 1 to infinity. So we can say that the integral from 1 to infinity of 4x e to the minus 4x dx, we cannot evaluate an integral with an infinite limit, so what we do is we take the limit as a tends to infinity from 1 to a of our 4x e to the minus 4x dx. Now we've just evaluated that integral, so this becomes the limit as a tends to infinity of, well, it was minus x e to the minus 4x minus a quarter e to the minus 4x. And of course, since we now have limits from 1 to a, we don't need the constant of integration written in there. So now we can substitute a and 1 into these, and we'll get the limit as a tends to infinity of minus a e to the minus 4x minus a quarter e to the minus 4a, and then we substitute 1 in, remembering we're subtracting both of these things. So this we can say is minus, and again we get minus e to the minus 4, and then we get minus a quarter e to the minus 4. Okay, well, we can see these last two values here, the minus e to the minus 4 and the quarter e to the minus 4, they're just constant values. So when we sort those out, we've got, in fact, minus the minus, so that becomes positive for both of those. So in total, we got 5 over 4 lots of e to the minus 4. And then we've got to consider what happens as we take the limit as a tends to infinity of these two expressions here, the minus a e to the minus 4. My apologies, that should be in an a. We substituted a in for x, didn't we? And minus a quarter e to the minus 4a. Okay. So in the first case, we can see that is one of the results that we need to apply or know, is that the limit at x tends to infinity of x to the k e to the minus x is 0. So we can state, using that result, that the limit of this part here, it tends to 0. Similarly, as a tends to infinity, we've got e to the minus 4a. Well, as a gets bigger and bigger and bigger, obviously 4a gets bigger and bigger and bigger. But because this is e to the minus, we know that as that 4a gets bigger and bigger, e to the minus 4a will get smaller and smaller and smaller. So that in turn disappears towards 0. And so all we are left with is that result of 5 over 4 e to the minus 4. Okay. So what have we got? Well, we get, again, just 3 marks for this. So the first part is indicating that we have a limit as a tends to infinity, and using the idea of changing the limits to between 1 and a, and that will give us 1 mark, showing we understand what we're doing here. Then for recognising the limiting process and using it to show that these two terms here both tend towards 0, we'll give you a second mark. So these need to be stated. And then finally, for obtaining the correct answer at the end, will give us our third mark. Well, hopefully you found that solution helpful. For more support for your revision programs, please go to your Further Maths Support Program website.